Hello everyone. So let us start. I'm really happy to see here those who were here the previous week. So do you have any feedback for me about the tasks and tests? Do you have any questions? Because I do have a bit of feedback concerning the task, the assignment on the site. So for those who are here for the first time, I will share the link to the site where you can find all the materials and tasks after the lecture. So those who found some time for the task this week, they tried to communicate with GPT on the topic of their research interest. According to Zipf statistics, half of all the employees nowadays use generative artificial intelligence technologies in their work. I do believe that in fact the amount is higher, but not for all the tasks we are permitted to do so. In fact, of course, so once again, the idea behind this course is that we should not use GPT and equivalents for our research papers, because they process all the data from the internet. Like we do not use Wikipedia and we do not use the links to Wikipedia in our sources. It's not reliable. Hopefully you do not do so. We shouldn't just use GPTs. In 2 weeks we will try out a few engines for researchers that process scientific articles, and also in the second half of the course we will figure out how we can use some open libraries to do the same, to process the texts of the articles, to figure out some tendencies, trends, and so on for your research papers. But up to now, we have just communicated with GPT on the questions of your research papers. Of course, we mentioned the previous time that GPT makes up some facts, makes up articles, authors, quotations, and stuff like that. But I do want to share with you a few remarks of those who have already done the task. First, I liked how it was put in one comment that it can help connect ideas from various studies. Indeed, GPT is quite good at summarizing. That might save our time. However, the tool has difficulties when answering series of questions. So on the one hand, we all know that it is better to give a few prompts on the same problem to get a more detailed answer. Nevertheless, on the second or third query, it sometimes tries to provide some repetitions for us. So it seems like the first prompt, the first answer is the most like giving us the whole picture, so to say. So there are a lot of repetitions. Also, it was marked by students of biology faculty that if they use terminology, the answer is worse. So it doesn't always understand all the terms. Of course, not general ones, but some specific ones. And finally, another thing that was mentioned is inaccuracy, not only in some facts and theories, but also in the description of experimental procedures. I do believe it is as well very important if you try to analyze other studies to figure out your own experiment then, to plan your experiment. And one of you shared with me a very beautiful chart created by GigaChat, and if it's okay, I want to share it with you. This is what GigaChat generated as an answer to such a question about statistics. That's interesting that it generated just the image, and you can see that there is some room for improvement still. Nevertheless, we mentioned last time that, of course, Russian-based, Russian-speaking GPTs, in some cases, they give, like, of course, they are not competing with GPT by OpenAI. But if we deal not with technical questions, but in humanities, if we deal with something about Russian, I don't know what, phenomena, then sometimes it's better to use Russian-speaking GPTs because English-speaking ones, or those who have English as their first language, they might not know anything about those. So today we will look at how natural language processing works in a bit more details, but still from the user's point of view. And next time we will try to look at the back end of them using some pieces of code, some snippets of code. So is it typical? Do you often use autocorrection tools? Do you rely on them? No. And a few years ago, it was even worse, than now, trying to edit something automatically. And so our aim of today and the next lecture is to try to figure out for ourselves how it all happened that 10 years ago, it was absolutely awful, and the only thing that we had were such awful autocorrection tools. And now we speak about using some generative technologies even in our research, how it all happened. So today, we will first look into some functions of natural language processing, into the spheres where it is used. Of course, we can imply some voice assistance, for example, in any sphere. But some of the branches are just 100% relying on the tools. Then we will discuss with you from the linguistics point of view how it all works. And finally, we will try to figure out what is Zipf's law. Has anyone heard of it? Yeah, right, so you will help me. And finally, we will discuss as the case study the case of personal details, because all our data is processed by models, all our data on the internet, and we cannot delete it simply, and so we will discuss the case of Cambridge Analytica. I'm sure that a few of you have heard of it, just to emphasize, to underline, of what is the amount of data needed for a neural network, kind of to make a portrait of a person, which is quite hard for a human, in fact. So first, natural language processing. So nowadays, automatically, we can create any bilingual dictionary, any thesaurus of a language. By the way, what is a thesaurus? How can you define this type of a dictionary?
It's a dictionary that has synonyms and
synonyms, true. So if we look at the structure of it, how is it structured normally? Only relying on synonyms or something else is used for this classification, grouping of words? Something else, sure. We will discuss it in a minute. And of course, nowadays when we have these huge data sets of texts, automatically to create such a dictionary is just faster. Then the next thing is that working with documents. So when we Google something today, what do we normally ask just for keywords, search for keywords, or what do we search for? How do we put our query? Yeah?
We know that Google search isn't people understanding, and that's why we use only words that we should try. For example, if we try to find the number of megapixels of camera, we write model of phone megapixels, and Google neural network can show us an answer from Wikipedia. And if we try to find something more deeply, we try to find people's generated content on this theme, and we try to find the same.
Okay, so if we just follow, as you mentioned, the keywords, then in some cases, just the most popular sites will be given. Nevertheless, all the search engines nowadays, they have inside them so-called semantic search. What is meant by it? The answer is lies first in this defining the subject of the document and then clustering the documents. So if we put a whole question to the search engine today, and in 2 weeks we will look at the search engines which work on the basics of research papers. So then they try to give the whole answer to you, and you have just the summary, yeah? And then you have the sites enumerated not according to their popularity, but according to whether they can give the answer to your particular question or not. And so the processing behind is about working with documents, sites, and figuring out, retrieving the information from those sites. Another thing is clustering and classifying. By the way, what's the difference between those two methods in terms of machine learning? What do you think? Clustering and classifying, classification and clustering.
When we classify something, we usually already know which categories we want to put objects into, and classification is just trying to also derive these categories from the data.
Absolutely. So the first approach, classifying, is supervised. So it is based on the parameters pre-given to the model or to a person who is doing this grouping. And as for clustering, it is kind of data-driven approach. It is unsupervised, and the machine just analyzes the data set and then makes some conclusions. And so normally, of course, if we speak about semantic search, classifying is kind of the first stage, and clustering is the main one, because only getting the parameters also from the data given, the answer might be more comprehensive, so to say. Then the next and even more challenging procedure method is so-called named entity recognition. Has anyone heard of that? Named entity recognition. Because initially, this method started to develop with working with proper names, because in texts, of course, we come across a lot of proper names. What are proper names? What might be the proper names? Any examples? Yeah, okay. So some landmarks, fine. What else? Sure, yeah. What else?
City name.
Absolutely, yeah. Locations. Brands, true. So any proper names. And initially this mechanism was used in tagging, whilst we can tag all the words with their parts of speech, and we will do it a bit further with you. And all the names were some kind labeled as well, yeah, as people, places, brands, and so on. But nowadays, language models, they use the same technique, the similar technique, to work with each particular word, again to figure out the meaning, the thing that we started with you the previous time. Not just classify everything or cluster, but trying to figure out the specific characteristics of any particular word. Fine. What do you think? What is a semantic map? Okay, we will even have the opportunity to learn how to make semantic maps, but this is closely connected to the issue of semantic field, and today we will discuss what it includes. And finally, of course, it's quite easy that with paraphrasing, like with summarizing, any automatic generative tools are quite good at. Finally, sentiment analysis. What does that mean? What types of documents are normally analyzed in terms of sentiments? And what is the purpose?
Social media posts.
True.
To, for example, get some info how a product is perceived by people.
Absolutely, yeah. So normally first with that comes the reviews, some reviews, and also, of course, social networking. So sentiment analysis normally gives the evaluation to all the reviews or posts on a particular brand or item to figure out five types of evaluation, from absolutely positive to absolutely negative. So these are the main functions of natural language processing. Of course, this is not the whole list, but these are like the basic ones. But let's start from the very beginning and again come back to the middle of the 20th century and have a look at the first well-known, at least try, of creating a machine translation tool. It was called Georgetown IBM Experiment. It was held in Georgetown University. And the idea was to provide some translation from which language to which? Russian to English, absolutely. So a few texts, scientific texts, were taken. And the interesting thing is that all the Russian words were Romanized because it was absolutely impossible at that time, at least it would have been extremely time consuming to make the machine learn Cyrillic alphabet as well. And so it was just translation word by word. What do you think? Was the result fascinating or not? Absolutely not, of course. So it was even worse than the thing that we had like 5 years ago from Google Translate, for example, because this was the first attempt of using so-called rule-based technique for machine translation. Nevertheless, rule-based techniques, they are still integrated into modern language models because anyway, although the main thing to analyze is context, as we settled with you the previous time, but still as the basics, of course, they consider some types of bilingual dictionaries, of simple grammar rules, of just definitions and stuff like that. This is all rule-based approach, and it is still used, but of course it is enlarged with other techniques. In fact, like in the 20th century, there were a few attempts to make this process of machine translation better, and even statistical methods, they appeared already in the 80s. However, what did they lack? What do you think? Why they were not successful?
about data maybe?
Data, of course. Data is the main thing. And as David Crystal says, one of the most famous linguists of our age, the language, of course, is hugely influenced by the internet nowadays. Nevertheless, he underlines in his book about the connection between language and the internet that sometimes this connection is overestimated because the mechanisms, in fact, they are the same. And centuries ago, when some new technologies appeared, new words did so. Nevertheless, nowadays, of course, it is very, very fast. And that is why those rule-based approaches, based just on dictionaries, they are enhanced with machine learning statistical approaches, which were not, for machine translation at least, very successful. But then come the deep learning approaches. We touched upon the deep learning last time, and here was the kind of advancement that we can witness now. So, any questions about natural language processing? Let us then go a bit deeper into linguistics. So what do you think? If it's called distributional semantics, so once again, what is semantics, first of all? What does this branch of linguistics study? Meaning, absolutely. So it is connected to the vocabulary, yeah? Not grammar, not pragmatics, but vocabulary. What about distribution? Then distribution of what? Okay, yeah, what can we look at in contrast to just a dictionary, a translation or a definition? Sorry? Context, absolutely. So distributional hypothesis is to do with context. In fact, it was formulated again back in the middle of the 20th century by this guy, John Rupert III. And he formulated it the following way, as you can see on the screen. And indeed, nowadays we know, especially if looking at machine translation back, that if we analyze context on different levels, around the sentence, around the utterance, around the token, and so on, then the machine can make much better results, can achieve much better results than just following some statistics. And that is how it is used nowadays. We will try out those first models of embeddings next time from the backend. And now let's have just a look at first just at this image, I would say, and then at we will look at the matrix of terms and documents. But here what is meant, which words are closer to each other from this picture? Of course, cats and dogs, and the machine just relying and analyzing the context can make the conclusion that both grammatically, in terms of grammar, in terms of the vocabulary, some words are closer to each other, others appear to be a bit farther from the keyword. And this is the way how autocorrection works, yeah, and how AI generates text. So it figures out which word is the closest to the one that you are searching for, to the one that you have already printed, and then it suggests something which seems the closest one in terms of syntax, vocabulary, and pragmatics. By the way, what does pragmatics deal with? So syntax, grammar and vocabulary is clear. What is pragmatics in communication? What else is important in addition to learning vocabulary and grammar for us and for the machine as well, if we try to communicate successfully?
Being clear, knowing how to use it.
What does mean know how to use it? What's the key to success? Appropriately, yeah, right. What does it include, this appropriate? Because if we use a foreign language, sometimes we use the words inappropriately, yeah? And it's not only about collocations, it's not only about grammar mistakes. What else is important? Okay, context, yeah. But what else can we learn from this context then?
We learn how to define words with different meanings.
True, but this is still in terms of vocabulary, that, okay, relying on the context, we need to figure out, fine, but what else is important? What else do we have as humans in our brain? We discussed cognitive linguistics last time with you. What helps us to communicate?
Okay.
What helps us to choose the correct meaning?
Things like intonation, mimics, gestures.
Yeah, sure. It helps us to overcome the difficulties in communication, yeah, non-verbal stuff, which the machine lacks, of course, right?
The real world
So yeah, as they say, it's about, first of all, associations, so something which is very personal, but still something which is like we are used to. And on the other hand, it's about concepts, yeah, that again, this is very culturally defined, whether some people, what they will understand behind just the meanings, the definitions of words from the dictionary, because it's quite easy for the machine to process the definition. But different people will have different associations with a table, and they will have from different, for example, cultures, they will have different concepts of something which is not from the physical world, at least. And so this is harder than to draw such vectors and to count them, to measure them, if we deal with associations and concepts. Right. But still, back to something easy, which is vocabulary. So have you ever heard of paradigmatic and syntagmatic relations of words? Okay, so we will just figure out a few linguistic categories which underlie those processes of machine learning in terms of text. So in general, if we speak about vocabulary and partly about grammar, to figure out, to analyze the context, the machine needs, first of all, to compare the words in terms of their, I think, first of all, syntagmatic axis. Syntagmatic axis, it is horizontal, and it deals with the way words are connected in the sentence. So this is about idioms, about collocations. What is a collocation?
It's the most common use of two words together.
Absolutely, 2 or 3 words together. For example, how would you translate сильный дождь? Sure, yeah. Why not hard? Why not strong? Okay. Крепкий чай. Крепкий чай.
Deep tea.
Strong tea, absolutely, and so on. This is the way that is analyzed, and of course the machine needs, again, processing different examples of using this particular word to figure out, and the problem is that in some cases in the data set, the collocations are used incorrectly, because the data set is in general not the whole, all the texts on the internet, but still it's quite huge. Right. So this is about syntagmatic axis, and in fact I planned to give you a collocations quiz online, but we found the internet just before the lecture, so let's just a bit play together with each other collocations. Will you now take a minute and prepare a list of 3 to 5 collocations in Russian, and then you will exchange those lists. You can just orally test each other or exchange papers, and find equivalents in English to those collocations. Probably it's good if you come up with something which was surprising for you when you studied English and so on. Is it clear what I want you to do? To illustrate the syntagmatic axis. Right, so take your time now to note down a few collocations in Russian first. And it's better not to use any devices now, otherwise it doesn't make any sense, okay? Okay, so let's come back to what we are discussing. That was the task just for you to illustrate this syntagmatic axis, yeah? Which lies, of course, is fundamental for trying to predict something for the machine, yeah? I do believe that after this task, during today and tomorrow, you will come up with collocations and think, oh, that was the beautiful one and the most surprising. And if you are interested in it, when you look through the notes of the lecture doing the test afterwards on the site, there is this link to this online collocation quiz. You can check yourself, yeah, how good or bad you are at this. And now let's discuss. So we've tried to illustrate syntagmatic relations of the words. And now let's look at the vertical relations, which are called paradigmatic axes. So I think that the main paradigmatic connection was already mentioned today. Back from the syntagmatic to paradigmatic. So what do you think? What is the main paradigmatic relation between words, which lies normally in the basics of any thesaurus? Yeah, it might be if we discuss the forms of the words, and also what is important, what is this connection? Parts of speech, they always are the fundamentals of the thesaurus, yeah.
If something telling a story, these words be in one paragraph, in one sentence, such as cry, died, etc.
Yeah, this is analyzing the text. So synonyms were already mentioned, yeah? We have the main things about equivalence and oppositions, yeah? To group the words, the easiest way is to look at something which is similar and something which is contrast to each other. Let's have a look at other paradigmatic relations, two additional groups of how the thesaurus is normally classified. So how would you characterize such a classification?
Pronouns and pronouns. Well, the top word can be used to describe all the bottom ones.
Absolutely.
It's called hyperonym.
It is called holonym and hyperonym. And so, yeah, the idea behind it, I just want to skip these terms because paradigmatic and syntagmatic relations were good, and you will find in the notes of the lecture these particular terms if you're interested in them. So, in addition to synonyms, antonyms, we can group the words by the general term and just the additional types, yeah? And another thing, how we can group something, how would you characterize this group, this classification? Yeah, okay, this is the example, but it's not about, we can say that a leg has the same relation with body like we had dog and animal. It's something different. So what is this relation? How would you?
Associative tree, like that.
It's good. In fact, we will come up to it, but it's not about associations.
I think it's like a part, so a noun is a part of the part.
Absolutely, yeah, whole and part. So we have main three groups of paradigmatic relations: synonyms, antonyms. Also, just groups, different groups, the umbrella term and some particular classes, and then we have the classification of the whole and the parts of it. And all those relations, paradigmatic axes, help the model to come up with a better text. So first, of course, it analyzes syntagmatic relations, and then it tries to make it better, analyzing paradigmatic relations. And of course, all those vectors, they are not the same, because some words are closer to each other if analyzing the context. Some are not so. And in general, all that makes semantic field of the word. Yeah. So where are the? Let's start with syntagmatic relations. So which groups of the field? Here, two groups. They refer to syntagmatic relations. Which ones? Actions. Absolutely. Yeah. And actions, yeah, actions of the subject, actions towards the subject. Right, which two groups deal with paradigmatic relations? What else? Positions, yeah, these are the paradigmatic relations. And here is the key to success. So this is just rule-based approach definitions, yeah, that we start analyzing a term with a definition. But then we need to look at collocating this term. Then we need to look at different similar words, synonyms, holonyms, and so on. And then the key to success is here, this associations, what is behind the concept for a person. So it is called word relativeness, whether a word is appropriate for a situation, for the audience or not. And this is the hardest part to analyze for automatic tools. What else is important here? Yeah, I do believe that the second, and I do believe the last task for today, is for you to draw a semantic field of a term, one or two terms. You can do it in pairs in English concerning your research area. So for example, if we take neural network here, we will say that we can teach a neural network. We can teach it, it can learn. The equivalent will be AI, unfortunately, yeah, we normally use it. This is the associational equivalent, although not straightforward. Or we can say as equivalent, not 100% equivalent, but 70 or something, transformer or GPT as an association here. Opposition would be something natural brain, yeah, or something like it. And the definition would be, okay, we can skip it because we can look it up in the dictionary. So will you take now another 3 minutes and in pairs draw a semantic field following this scheme to any term of your research interest? Is it clear what to do? Okay, take your time. So now let's discuss what is Zipf's law. So somebody said that they have heard of it. What's that?
If we generalize Zipf really much, it says about the principle of least effort. So any system, maybe thermodynamic, maybe a human, always takes the path of least effort. And if we try to look at the Zipf's law through the linguistics approach, it would be about distributions of words.
Absolutely. So by the way, which parts of speech are most frequent?
Nouns?
No.
In English is the article the.
In any language, just in general or in English. Okay, let's take English as an example. Not nouns, what else?
I don't know the word in English.
Huh?
I don't know the word in English.
What do you mean, the word?
Vvedение.
Okay, yeah, so some function words, absolutely. It would be about function words. Which types of function words do you know? Conjunctions, prepositions, and stuff like that. So these words would be the most frequent, and this is the distribution in terms of linguistics. So the Zipf's law looks like that the frequency of the word So each word, according to this law, has its rank, and so the frequency is interproportional to the rank of the word. So the more meaningful the word is, the less would be its frequency in the text. Moreover, if we take the first ranked words, then normally in most languages, like in English for example, the most frequent word is used twice as frequent as the second frequent one, the third twice less frequent as the second twice frequent as the third one, and so on. What do you think? Just particular examples. What is the most frequent function word in English? So we've decided that this is about articles, prepositions, and so on. So what is the most frequent word in English? Hello, there, absolutely, yeah, I've heard there from a few angles. Let me check up the second, I always mix it up. Yeah, what is the second one? So there is the most frequent word in English. What do you think, which preposition is twice less frequent but still has the second place? Preposition, a tip for you. No, not particle. Preposition, yeah, one of the prepositions. Not in, on. Off, yeah, this is off. Right, okay. And what about the third frequent word? So the third frequent word is used twice. The second is used twice as usual as the third one. What is the third word? Okay. Sorry?
Indefinite article.
No. And I think that somebody mentioned it. So there, of, and these are the most frequent words in English. And in fact, most of the European languages like German, French, Italian, so coming from the same family, and Russian as well, they follow this this formula. Okay, let's take Russian now. What do you think? Which words are the most frequent in Russian? Any more? Okay. Any more function words in Russian which might be frequent? Okay. We will, yeah, that's the question. Yeah, in fact, the conjunction "и", then the preposition "в", I won't guess it, and then comes the particle. So the frequency of the words is counted in instances per million. So we have a corpus of words, and the words are used a few times in it. And the instances per million, this is the measure for the frequency of a word. For example, in a corpus of contemporary American English, the so-called COPA, here we can here the frequency range is analyzed. The same too works with the British National Corpora, and I suggest that now we deal with Ruscorpora.ru, which is Национальный корпус русского языка, КРЯ. And so let's, for example, count there, dog or cat, собака или кошка, has the higher frequency range. What do you think? Dog or cat will win? In Russian. Okay.
I think we need to vote for this question.
A vote, okay, yeah, that's a good idea. Let's double check it with NPR. I will show you how it works with the word dog, let's put it, and then you will try it out yourself with cats. Okay, so have a look. You will follow the link ruscorpora.ru. But before that, let me show you how to do search here, where to find this frequency range. So let us first check the dog. So we search for the word. So national corpus of the Russian language. Oh, it's not fast at all. So when you make a query, the question is whether you want to search for some particular forms, and then there are fewer examples, or you search for the word in any form. Then, of course, there are more examples. And so we'd prefer now the second variant. And here, and we can use the main corpus, or there are some particular corpora inside it. For example, based on social networks or stuff like that. So this is to deal with the types of texts in particular corpus. Okay, let's once again search for okay, yeah. Here we have finally the examples of the word that we search for. We can sort them or filter. A bit later with you, we will discuss what are n-grams, b-grams, and so on. And now let's look up the frequency of the word. And yeah, finally we get it. So here are those instances per million of the examples of dog used in National Russian Corpora, or the National Corpora of the Russian language. Will you now follow the same stages to search for the cat? Только не кот, а кошка давайте искать. So, Ruscorpora, you search the word, you choose one of the types of the search, it doesn't matter. Then you choose frequency, and you need to figure out what is the amount of instances, what is the number of instances per million. Absolutely, 40 and something. So we can make the conclusion which word is more frequent. Absolutely, yeah, 3 times more frequent. Although at the beginning, there was a suggestion to make a vote, but we didn't get like 100% answer that of course it's a dog. We are all Russian speaking, most of us. Yeah. Fine, so this is how it works, how this frequency works with, this was the illustration how we can check up this frequency of words in national corpora. So any language, most of the languages, they have national corpora, and there you can find such information. As for our projects here, we will bear in mind that as for fiction, they do not think, researchers, that this frequency of words can prove any theories about the style of the author or something like that. So there are debates about it. Nevertheless, if we look at scientific articles, scientific papers, not at 10 but at dozens, at thousands, then when we can figure out some tendencies according to the frequency of some terms, of some formulas, and so on. And this is what we will, where we will try out the tools that we discussed with you. So before I share with you this case study about Cambridge Analytica, let's discuss the final thing for today. And this is called this vector representation. space, because we need to bear in mind that each word has a lot of vectors. It's not just 2, 3, but this is about millions of them. That's why it is three-dimensional. And normally, these vectors between words, they are counted per documents. So in this term document matrix, normally we have here on the rows terms, and then we have on the columns documents, and we can figure out whether a particular term, this one, for example, is important or less important for this or that document. Of course, the easiest way is just to count how many times it was mentioned. But more complex processing tools allow us also, for example, to follow the sentiment analysis or to analyze it from different angles. This was taken from a paper on the analysis of Shakespeare's plays. And here the words were just counted. So this is the example of the research, which is debatable a bit. Nevertheless, we can see that, for example, it's quite easy to guess that the word battle, is used in the play about Henry V more often than, for example, in the 12th Night, it's not used at all. So this is how it works, yeah, a simple example of the term document matrix. So, case study. What have you heard about neural networks processing our personal data? What are the main reasons and aims of doing so? What data is important and stuff like that? Do you feel that your data is processed?
Yeah.
How come?
For example, with marketing, when you have targeting advertisement.
Yeah. Absolutely. What else? So if I search for something, for sure, some offers would kind of follow me a few days after, right?
Okay. Do you think that AI will divide our data? If we write a sentence, he learned it to a model, and after that gives another user an answer with this data, but it feels like our secrets and our NDA data don't appear in a complex view. It appears in a very divided view from one word in different sentences.
Absolutely, that's true. For example, yesterday I do believe, if I got it, the example of that. I discussed it with a few people, but just in personal messaging. We need a teacher of Python for our master degree program. We need to change him, and but I discussed it only in messaging. And since yesterday, I have a lot of offers of online Python courses. So they just analyzed, and not from my search, but from my personal messaging, that I'm interested in learning Python. But it didn't get, the neural network didn't get that what I'm looking for is a teacher. It just offers me courses. So this is how, yeah, indeed. The main reason is, of course, to offer us something, to get money from us, but not only. So this is how the sentiment analysis vectors are prepared by a model. So if it analyzes some words in the reviews, it can figure out whether the positive or negative attitudes in this particular case refer to some point, yeah, to evaluate these positive or negative attitudes. Wait, do I have, I know this is about course already. Yeah, so personal data. Have you heard of Cambridge Analytica case? Yeah, so what was it about? Yeah, indeed. So it's like two-sided, because on the one hand, there is a scientist called Michael Kaczynski, and he's still quite respected. And once he worked out an app called My Personality. It was an app to analyze some personal details of users who agreed to it to do some research. But then it seemed that these mechanisms were used by another application, Cambridge Analytica. In fact, both of them were closed after the scandal because Cambridge Analytica, so the connection between Michael Kaczynski and Cambridge Analytica was not proved. But it seemed that very similar methods were used by Cambridge Analytica in the years 2015-2016, I do believe, in 2 elections, which were quite surprising. First of all, first campaign of Trump, yeah, so the result was rather surprising. And second, Brexit. What was the mechanism used? So the neural network analyzed the profiles on the social network of the users, and then it offered some kind of not just advertisement, but social advertising and some kind of information which influenced the kind of position of this or that person according to their personal preferences, according to the portrait, the psychological portrait of a person. And of course, we all understand that nowadays neural networks some kind of follow these similar mechanisms, although those 2 apps were closed. But what do you think? So there were some research articles written about that particular case, and it was analyzed and figured out the approximate amount at that time of not likes or comments, but just clicks on the social network, which was needed to be processed for the neural network to make the portrait of a person similar to the one that his employer has. So, okay, our employer, for example, the university, knows something about me, yeah, about my education, about my social status, about my probably some family issues and stuff like that, yeah? So what do you think? How many clicks on a social network need to be analyzed for the neural network to have the similar portrait? I don't know, 1,000 of clicks, 100, 10 clicks. Not the data itself, but just clicking.
1,203,000.
100.
100 is closer, even fewer. 50. In fact, according to that research, it was about 70. So just 70 clicks. So we can imagine nowadays, about 8 years afterwards, with modern transformers, with all the data that we have on the internet, how deep they know us, yeah, with those deep learning. Right, so that was just to illustrate this sentiment analysis. The course requirements for those who were absent the previous time. So I will share with you the QR codes once again to the site, where there are all the lectures, the notes to them, and probably video recordings will appear there. And after each lecture, on Friday, a test, multiple choice quick test, appears there, and you can double check the lectures, the notes for the lectures to answer this test, or you just can rely on your intuition. Then it would take, I don't know, 5 minutes, yeah, to click it. If your result is not good, it's not a problem, so it's not just counted to your portfolio. And then after each lecture, there is an assignment, which might take about half an hour. So the previous time I asked you to discuss your research interest with GPT, and today I would like to ask you to look through a book. I will share it with you, a kind of booklet with some examples of natural language processing projects, and just to share your opinions about those projects. So you will have the opportunity to choose one of them and write a few lines about it, just for you to go deeper into the topic. And from probably the 4th class, you will already deal just with the texts of your research interest and process them with different tools within those tasks. To get the credit, you need to do 75% of the tasks, and the tests and tasks are available from Friday till Wednesday, till next Wednesday. So this course is supported by Intellect Foundation. They have a few interdisciplinary courses within Moscow State University, and this is the general rule that the tasks, tests, and notes appear on Friday. It's quite reasonable because if you take and do it a few days after the lecture, it would be much more resourceful for you, so something will stay with you. So here is the QR code to the channel, I think, or to the group on Telegram. If it doesn't work, you can take these printed versions. Right. Do you have any questions? Then see you next week. We will try out some code snippets then and look from the back end at the language models. Thank you for coming. Bye-bye.